Hello and welcome back to the 8-Bit Guy. So today we're going to be having a look at a very special computer. Not so much the computer itself, but because of who it belongs to. So you've probably already read the title of the video and you know this computer belongs to Martin Galway. In case you don't know who Martin Galway is, he's a famous chiptune musician from back in the day. He has over 60 credits for famous video games, a lot of them on the Commodore 64, but also on pretty much every sort of system out there, ranging from the NES to the Amiga. Later on in the 90s, he did music for MS-DOS games like Wing Commander 2 and Ultima 7. Here's a picture of Martin at work, and if you look behind him, you can see part of the computer that I have here. So now you're probably thinking, but wait a minute, doesn't Martin Galway live in the UK? Hence the UK power connector on the back of this computer. Well, yes, he did, but a few years back he moved to Austin, and I met up with him there a few months ago, and he asked me if I would take a look at this computer because it is not working properly anymore. So let's have a look at it. This is my first time actually handling a European 128D. Remember, here in the USA, we never got this machine. We got the 128D cost-reduced version, which was made of metal and was not considered portable in any way. Okay, here's the keyboard. Yikes, that is yellowed. Since this thing runs on 240 volts, I'll need to use this transformer with it. And since it's PAL, I'll also need to use this PAL monitor with it. Martin also gave me this UK power strip. So I just wanted to mention, I talked with Martin about possibly cleaning this thing up and retrobriting it, but he decided he wanted to keep it original due to the various stickers he has on it.
So one thing that stands out to me is how dark the phosphor is on this 1084 compared to the ones I've seen here in the United States. This one's almost black by comparison.
Here's another problem I ran into. This monitor has a SCART connector on the back. Nothing ever used this connector in the USA, and so there's nowhere for me to plug in my LCA wires. Fortunately, it does have composite video, so I'll just use this. Yes, this particular cable uses red for composite. And it does appear I can also use the RGBI cable for the 80 column display, so I can test that too. Okay, I'm gonna power it on for the first time. And this is what I get. Yeah, there's definitely something wrong. I tried rebooting it in 80 columns mode to see if there was any better luck there, but nope, nothing. So I began the process of disassembling the unit. This will be my first time looking inside of one of these European 128Ds. Interesting, so the 1571 disk drive inside has its own separate board, which looks pretty much exactly like the one you'd see inside the dedicated disk drive.
So it's interesting that the RF shield has this typical slant in front of it. It's probably the same shield they used on the flat version of the 128.
The RF shield also doubles as a heatsink, but for the moment I'm going to clean all of the heatsink compound off these chips so that I can tell what they are. Okay, now that everything's cleaned up, I'm going to start troubleshooting. The first thing I usually do is check the voltage, and we do have a good 5 volt reading. But when I went to test the 9 volts AC, I found basically nothing. So ideally, I'd like to plug in my standard 128 power supply, but mine has a connector like this, but they didn't populate that connector on this board and instead gave us this pin header here. So what I'm going to do is use my Nubrick power supply and this female dongle, and that should give me access to the different wires. I'll use some of these alligator clips to connect it to the header. I know this looks questionable, but I checked with the meter before plugging it in to make sure nothing was touching that shouldn't have been. Okay, time to try it again, and well, nothing. So, as I feared, there's probably more than one thing wrong with this computer. Next, I decided to take apart my flat C128 so I could start swapping chips around to see which chips do or don't work. And I already know that certain chips probably aren't compatible, like the video chip, because mine's NTSC and Martin's is PAL. And to make matters worse, a lot of the chips I wanted to swap are soldered directly to the board in my 128, which makes this a far more challenging job. I still couldn't figure out what was wrong with this power supply, and I was feeling a bit frustrated, so I called up a fellow Texan. She's probably the world's foremost expert on the C128, next to Bill Hurd himself, and she was happy to come by. This is June from YouTube channel Nybbles and Bytes. She jumped right in and got straight to work, and she also brought some equipment I didn't have, such as this nice oscilloscope. And the first thing she wanted to do was verify all the clock signals, starting with the main crystal, which was outputting a proper 17.73 MHz signal. Next, she found the 4 MHz clock, and that was working. But when we got down to the CPU clock, there was nothing. Okay, so I have to explain something here. June and I were both under the impression that this computer would actually boot and run with just the 5 volts DC. The Commodore 64C works exactly like that. If you don't have the 9 volts, but you do have 5 volts, it'll still boot, and I think it won't have like audio, and I think the user port and cassette port don't work, but otherwise the machine will still boot and run. And so we thought the 128 was like that too. It wasn't until June traced down the lack of a proper clock signal to the lack of 9 volts that we realized this machine would never work without it. That being the case, June turned her attention to the power supply to see if she could figure out why it wasn't working. And after a few minutes, she realized what the problem was, kind of by accident. She noticed when lifting the board by the 9-volt transformer that it really wasn't attached to the board on one side. Well, that's certainly a problem. She thought she might be able to repair the transformer, so she desoldered it from the board, and now you can clearly see where it was broken. So I asked Martin how this computer was shipped from the UK to the USA, and he said somebody had actually brought it over in their luggage. And we all know how the airlines treat suitcases, so I think it's a pretty safe bet that that's when this was damaged. June attempted several things in order to make it work again, but ultimately found that the windings seemed broken inside the transformer because no current was passing through the coil. So we gave up on fixing that and returned to my idea of using an external power brick. But this time June decided to desolder the power cable from the old power supply and solder it to my new brick. Now, we weren't actually expecting this to fix anything, but figured it would help track down the secondary problem. However, when we powered the unit up, the thing just started working. What the heck? I have no idea why it didn't work for me when I did this earlier. However, our celebration was short-lived because the monitor eventually went bonkers, and it was doing this on both the 40 and 80 column display. We were pretty sure this was a monitor problem, but I looked all around and tried a dozen monitors, and I just couldn't find anything around here that was PAL compatible. I think a lot of people just don't realize how rare PAL equipment is in the USA. I even tried a couple of modern LCD monitors thinking that they would support PAL, and they didn't. However, we eventually got something working by using a video capture device that supports both PAL and NTSC, and at this point we performed a number of tests, including playing Petsky Robots 128, which uses all 128K of RAM, so we thought that would be a good test of the RAM. 2 weeks later... Okay, so finding a transformer that fit the volts, amp, size, and pinout proved to be impossible, but June found this one that's a close match, at least electrically speaking. So now the challenge is to figure out how to mount this thing in here. It looks like mounting it sideways and bolting it to the inside wall may be the best bet.
So one little observation that I want to make is that this goes inside of there, as you've seen. And then, believe it or not, the way this thing mounts in the machine is actually upside down. This is the top of the power supply, which means that under normal operation, this board is hanging upside down, which would explain why this transformer broke so that means under any heavy jostling of this machine, that means this power transformer is going to be prone to wanting to break off, and that's exactly what happened.
Okay, time to drill some holes. I did check with Martin before doing this, and he said it was fine. Okay, so I've placed all of the original wires back on, and these wires are for the transformer, as are these here. Alright, let's screw everything down. I'm going to put a zip tie through these holes, as I may need it to help hold this thing in place. To make this fit nicely, I'm going to need to bend these leads. And here we go, let's bolt this thing on. It turns out this thing is mounted so strong, I won't even be needing the zip tie, so I'll pull it back out. And now I just need to wire this thing up. The middle 2 leads are going to get connected together since we're doing 240 volts input. And the reason I'm not bending these wires through the holes is to make it easier to get the heat shrink over when I'm done. And after one final check, I sent a photo to June and she noticed I made a mistake, so I'm going to need to move this wire over to a different lead. And there we go. Everything looks nice.
Okay, everything is put back together. I'm plugged in the transformer, but I haven't turned it back on yet. I'm not going to lie. I'm actually a little nervous about what might happen. I've found myself in this sort of situation before. Everything looked good. Turned the power on, and, well, things went south. So, anyway, so yeah, I'm going to turn it back on. Technically, nothing should happen. And then, assuming nothing happens, I'm going to check the voltages and everything. If something blows up, then, well, we'll deal with that. All right, here goes. Okay, good. Nothing happened. Let's check voltages.
Checking the AC voltage coming out of the power supply, I'm reading 12.93 volts. Now, that's a bit higher than I was expecting, but there's also no load on the transformer. I checked the specs on the voltage regulator, and this should be fine. The next thing I want to do is add a little extra protection since the connectors on the transformer are so close to the metal case. So I've cut out a piece of cardboard and applied some mounting tape, and I'll just stick that right there, and that should work fine. And now to put the power supply back into the computer. Okay, the power supply is in, and I've been wondering what this toggle switch was used for. I had noticed that not only was it not connected to anything inside, but the guts of the switch were even missing. Well, I asked Martin about this, and he said it was to turn the fan on and off because the fan was loud. Well, that makes sense because he was working with music, but I guess the switch was removed at some point.
Okay, here's the big test.
I couldn't be happier to finally see this thing working. Unfortunately, my excitement was short-lived. I had tried loading a game from disk and found that the disk drive was not working. The drive acts like it's working, but I can't seem to tell that there's a disk in the drive. I tried several known good disks and constantly got the error message, "Drive not ready." Remember, when we ran the game earlier in the video, I was using an external SD card reader for that. So I called up Martin and I asked him if he knew if the disk drive worked the last time he powered up the system. And he said, actually, it's been a really long time since the disk drive was used. In fact, he said it was very rarely ever used, even back in the day. He said the way they did development was they used an Atari ST development system where they would do all of their coding and compiling, and it was connected to the Commodore 128 through some sort of cable, probably the cartridge port. And they would send the test code over directly to the computer without the use of a disk drive. So he actually said the last time the disk drive was probably even used for anything was probably around 1989. So who knows how long this thing has been inoperable. So we'll see if we can get it working again. I figured I'd run the diagnostic program, which would require connecting an external drive as drive 9. In the program, I can configure my working drive as drive 9 and then the drive to be tested as drive 8. I first ran the logic board diagnostic, which wanted me to verify a steady blinking LED, so for that I needed to connect the LED back up to the drive. After that, the drive will flash the result code on the LED, and a single flash means the system board is okay. That appears to be the case. So the next test I performed was a read-write test. I used an unformatted disk for this, and well, it came back and said the system is failing. Unfortunately, it didn't tell me anything I didn't already know. I decided to crack open my regular 1571. I needed to borrow the drive mechanism out of it so I could at least determine if the fault was with the board or the mech. Even though the logic board says it's good, there are analog components on there too that could have failed. Okay, so here's a known good drive mech. I'm just going to lay it on top and connect it in. And guess what? It's booting. So I know the problem is with the mech, but I can't visually see anything wrong. I did test the resistance on all 4 head coils, and they all showed around 10 ohms, so I think those are good. I removed it from the computer for closer inspection, but still couldn't see anything wrong. 2 days later. So I managed to find a local person who had a 1571 drive mechanism, but unfortunately this one is made by Alps, and the original is a Mitsumi. It's possible it may work, but there's another problem. The wires aren't going to be long enough to fit the 128D, and I had planned to transfer some of the sensors and stuff over to the new drive so the wires would be the right length, but I can't do that if the mechanisms are totally different. 2 more days later. Okay, so I just can't find an exact replacement, and I'm sure once the video goes live, there'll probably be 100 people raising their hands saying, I know exactly where you could have gotten the right transformer, and I know exactly where you could have gotten the right drive mechanism, but the reality is we looked around for a couple weeks and we just have not been able to find anything. So so what I'm going to do is I'm just going to go ahead and use the drive mechanism from my personal 1571, and then I think Bo Zimmerman may have a replacement for me when I go back to Austin next, so hopefully I can get my 1571 repaired later. Okay, so this is the original, and here's the one we're going to use. On the bright side, the drive head wires are already long enough. In fact, the new one's even longer. But these are the ones that present a problem. So what I'm going to do is unscrew a number of these sensors, like the track 0 sensor, the index sensor, the write protect sensor, and just transfer those to the other drive. See, here's a whole bunch of stuff I won't need to lengthen the wires on. I'll just reattach all of that to the new drive, and there we go. So here's where we're at now. At least half of the wires are now long enough without cutting anything, But if I swap out the stepper motor or some of these other things, I'll have to realign the head, which is not something I want to do. So I think what I'll do is just lengthen these wires, and the way I can do that is simply by cutting off the wires on the other drive and reattaching them. I'm going to try for the first time a new soldering method that has been suggested to me for joining wires. Well, I don't know if the joint's any stronger, but it is much easier to solder because the wires are linked together. And don't forget the heat shrink. And now this wire is definitely long enough. All that's left to do is this one. Okay, wires are all done. Let's reinstall the drive. Now it's time to test it, and there we go, it's booting. I think the computer is fixed. Time to reassemble. After getting it reassembled, I really wanted to get some sort of monitor working on it for when Martin comes back to pick it up for me. I tried another fancy modern LCD television, but it would only display in grayscale. And I thought maybe I could try the RF connection. Of course, I wasn't even sure what channel it would be on because the analog station frequencies weren't the same between the US and UK, but it did find a station. Unfortunately, the picture was even worse than using composite. Here's another LCD television from the early 2000s, but it just rolls. And then here's another modern LCD, and it doesn't even try. It just says an unsupported mode. So then I thought, what if I connect an RGBI monitor to the 80 column output? My understanding is the frequency used in the UK should be the same as the US for this type of display. However, that didn't work either. But I finally got something working. I had almost forgotten I owned this, but it's called a RetroTink, which converts vintage video signals to HDMI. And it didn't have any trouble displaying a picture for me. And a few days later, Martin showed up to see his computer. He seemed pretty happy that it was working again. I did apologize for not repairing his monitor, but that was just going to be a nightmare for me. So, maybe he can send it to Adrian or somebody for repair. By the way, if you'd like to see more repair videos, I've started producing regular videos over on the Time Rift Arcade YouTube channel, where I show how we're repairing these arcade machines. It certainly has a lot of overlap into the repairing vintage computers, but, these machines come with their own set of challenges. So I encourage you to subscribe, and I'll put a link down in the description. But that's all for now, so as always, thanks for watching.